Okay, this is number 1 of 2007 FRQ. This is a graphing calculator required problem, so have your graphing calculator ready. I have a very, very, very old TI-83 with me, but it still works the same way. All right, so let R be the region in the first and second quadrants, bounded above by the graph of y equals 20 over 1 plus x squared, and below by the horizontal line y equals 2. So this is the top, this is the bottom. Even if you don't know what this looks like, at least this gives you a kind of a clue, all right? So first thing you want to do is graph it out and kind of see what this looks like. So y equals, I have my 20 over 1 plus x squared, and the bottom is y equals 2, all right? So when I graph this, this is what it looks like. Now it says the curve is on top, and then y equals 2 is on the bottom. So you cannot assume it's this region down here. You actually want the region on top. Now, how high up does it go? I don't know. So I'm going to use my calculator to help me figure it out. One clue is to look at the table. I want to look at the y value on the y-axis, which is when x equals 0. So if you go second table, you will see that the highest value goes up to is 20. I'm going to go back to my window and adjust it. So x value is fine. Y values, I don't need any of the negatives, so maybe -1. I want 20, so I don't want it exactly at 20 because I'll cut it off, so maybe 25, and maybe by 2s. The scale is really not super necessary. So, graph. All right, and there is my picture. So the most important thing you need from the graphing calculator is figuring out what that intersection is. You can see, and you can also see from the function, that this is a symmetrical function. So you really don't need the whole thing from left to right. You really just need it from 0 to that point. That would actually help us a lot. So let's use second calc intersect to get to that part as quickly as we can. All right, first curve, second curve, guess. It intersects at x equals 3. Beautiful. So that actually makes things a lot easier for us. Okay. So I don't need that. What I do need is kind of figure out what this looks like. So my picture looks something like this, where my graph is going like this somehow. Sorry, it's symmetrical. Y equals 2, and it crosses here, x equals 3. Now I know the left side and right side are exactly the same, so I don't need to do both. So what is the area of R? Well, part A then, the area of R, I'm going to double since I don't want to do -3 to 3. So 2 integral 0 to 3, top function 20 over 1 plus x squared minus a bottom function y equals 2 dx. All right. And again, if you are using an older calculator like me, you can follow my steps. But if you forgot, Math 9, the newer calculators has the integral notation. You can directly put it in. I would just double it at the end. So what I would do is make sure I put my parentheses all in correctly. If you have the older version, watch out for that. You want to parentheses the entire function. So parentheses, you have 20 over another parentheses, 1 plus x squared. Close that denominator, minus 2, close your entire function. All right. Do I really need that second parentheses? You know what? I don't. Sorry about that. So I don't need that set of parentheses. Delete. Delete. Because order of operation will tell your calculator to do the division first and the subtraction. Comma, x, that's your dx, comma, 0, comma, 3. Close. All right. I don't need to worry about mode on this one because there's no trig function. So go ahead and press enter. Let it think. It got me 18.98. And don't forget, now you want to double. So times 2, my final answer would be 37.962. Remember, you want to round 3 decimal places. So the area is equal to 37.962. Okay. All right. Part B. Find the volume of the solid generated when R is rotated about the x-axis. So here's the x-axis. It's going to rotate this way, which means my big R is up here and my little r is down here. Because it's rotating on the x-axis, you don't need to subtract the rotation axis because rotation axis is 0. So it makes it a lot easier. So your big radius is just your function, 20 over 1 plus x squared. Your little radius is just 2. The volume of this is pi. You could double this, but just for insurance purpose, I would just go ahead and put in -3 to 3. Big radius squared, 20 over 1 plus x squared squared minus 2 squared dx. All right, and so if you double this, you would just make it 2 pi here and 0 here. Same idea. All right, so now punching this in is going to take a little bit more finesse because of all the squaring and all the parentheses. But let's try again. Math 9. Okay, this time I do need the parentheses because I need to square this function. 20 divided by parentheses 1 plus x squared. Close your parentheses, close it again, square that, minus, just do the 4, all right? So, comma, x, comma, -3, comma, to 3, all right? Close your parentheses, everything looks good. Press enter. Let it think. My calculator's so old. All right, so I got 595.618. Don't forget to multiply your answer by pi because this is a volume problem. My final answer is 1,871.190. So 1,871.190. All right. Last but not least, this is a cross section. Wow, this is all chapter 5. The region R is the base of a solid. For this solid, the cross section perpendicular to the x-axis. So if we want to draw a clearer picture of what's happening here, you have your region like so, and you have your y equals 2, and your cross sections are perpendicular to the x-axis, so cross sections are here, right? And they're semicircles. So semicircles. Hopefully this kind of makes sense. You're gonna have to look at it 3-dimensionally, right? Okay. What is the key thing? The key thing is this region here gives us a diameter, and we don't want that. We want radius. So the top minus bottom gives us a diameter. Diameter is 20 over 1 plus x squared minus 2, which means radius is this divided by 2, right? So 20, 1 plus x squared minus 2, the whole thing over 2. Now you can reduce it or you can leave it. It's really up to you. Because what do we need to know? We're adding semicircles. So semicircles, the area is 1/2 pi r squared. This is already pi over 2 r squared. So this 1/2 here we can actually pull out if we want to, and it doesn't really affect our answer. So what does that mean? Well, the cross section, the volume of this is going to be integrating from -3 to 3, right? We're taking all of the semicircles, pi over 2 r squared dx. And my radius is 20 over 1 plus x squared minus 2, the whole thing squared, right? So let's see. We can take out coefficients. The pi for sure comes out. This is where you got to be a little bit more careful, but it's going to be super rewarding if you do this because it is less to plug into your calculator. So 2 squared is 4 times 2, that gives me 8. So -3 to 3, and I'm left with just 20 over 1 plus x squared minus 2 squared dx. All right, so last time using this, we want math 9, and now I need the whole thing squared, so I need another set of parentheses outside. 20 divided by parentheses 1 plus x squared, close that, minus 2, close that, square your function, comma x, comma -3, comma 3, close. That is my entire thing. Enter. It's taking a while. My poor calculator. All right, and don't forget to multiply your answer by pi over 8. So times pi over 8. Enter. My final answer is 174.268. All right, that's it for number 1.